So we're going to talk about sampling distributions. And before we do that, I think it's very critical that we go back and review what we did with probability distributions, because these are very similar with the exception of a couple things. And I think tying these two together, and if you can keep them tied together in your head, it will help make this make a little more sense and help you understand at least how to calculate these things. So let's review. First, let's review probability distribution. That's what we learned previously. And I should put a parenthesis here. We know the population mean and standard deviation. They were given by these two. We just said mu of x is equal to mu, or the mean is equal to the mean. And the standard deviation of x is just equal to the standard deviation of the population. So here we just took these as facts, and we just assumed that we knew everything about the sample or the distribution, excuse me. So here is, now we're getting into sampling distribution, where now we want to take multiple samples. So when we want to do that, we have to first define a couple other things. So a sampling distribution. You can pause the video and write it, and then come back and I'll read it, because I know writing and listening is kind of difficult. So go ahead and pause. Alright. Sampling distribution is the probability distribution, so what we just did up here. So sampling distribution is the probability distribution, what we just did up here, but this time it's for all possible values of the statistic computed from the sample size n. So now we're taking multiple samples down here, not just one like we were doing up here. So this changes the formulas a little bit. And so when you see an example like this on the exam, you need to determine if you're using a sample size and what is that sample size. So first, let's define this before I tell you what the new formulas are, I guess. You'll call them formulas. So for a sample, you can go ahead and pause again and write it, and then I'll read it. So go ahead and pause. So for a sample size n, that's the key here to know you're dealing with a sampling distribution. You have a sample size n with a mean of mu and a standard deviation sigma. That's the same as the first bullet at the top of the page, meaning up here. So far we're exactly the same, but now we threw in this n. The sampling distribution of x bar has the following. So now, instead of having mu sub x, meaning this is the population, now we have mu sub x bar and sigma sub x bar. That identifies that we're dealing with a population. So, a sample. So if you see x bar down here in the subscript, that means we're dealing with a sampling distribution, and now the formulas are going to change, how we need to calculate our z-scores. So it starts off pretty simple. Mu sub x bar, meaning the sample of the mean. So this means the sample. The x bar below means the sample. The mu means the mean. So it's the sample mean is equal to just the mean, the population mean, whatever we were given for the mean. Here's where it changes. The standard deviation of x bar, alright, it changes. And what its formula is, now remember, x bar means the sample, this means the standard deviation. So we're dealing with the sample standard deviation. So it's sigma, just watch me for a second, it starts out the same, but we have to add this caveat, divided by the square root of n. So we're dealing with a sample size of n, so we have to take that into account when we're dealing with dispersion, how dispersed this data is. We have to take into account that there's multiple samples we're going to be using, or that we can take from this. All right, and down here I wrote in exclamations where x bar identifies that you're working with a sample. So I just really wanted to get that into your head. So when when you want to find z, it still starts out the same as up here, except now we'll have x bar and x bar here and here. So we'll have x, which is the observation we're looking at, minus mu sub x bar, all divided by the standard deviation of x bar. All right, And these things, we can just plug in what these are equal to. They're over here. So this is equal to, on the top, we have x minus mu. So exactly the same as up here. But now we have to take into account the sampling standard deviation. Remember, x bar says sample, the sigma says standard deviation. So sample standard deviation is equal to this thing. So now this is what we're plugging in. So it's sigma divided by the square root of n. All right, and in the next video, we'll get into some examples of how this is working, and we'll also use the calculator.